today I'm going to work some problems from section 0.6 on factoring. What we are really going to be doing with all of the polynomials, algebraic expressions like the one that I have from number 4 up here, is we're really going to be multiplying backwards, or we're going to be looking at the expression each time and thinking to ourselves, using our techniques for multiplying polynomials that we learned in section 0.5, what polynomials did I multiply together in order to get this result? And so we're going backwards. That's what factoring is. If I were to do an example with numbers, I could look at the number 15, and if I say to myself, what two numbers did I multiply together to get 15? The answer would be 3 times 5. And so each of these are factors that I multiplied together to get this product, or this result. We're going to be doing the same thing with an algebraic expression, and we'll be trying to find the algebraic factors that we multiply together in order to get the expression. What the textbook does in the problem sets, and if you will look at the examples that I work, there's going to be one similar to all of the problems that you have in the assignment. What the textbook does is they tend to break the problems down into a certain method or technique that you would use to factor that type of polynomial. What we're going to do in this first example is simply try to find a common factor to every term in the polynomial. For example, if I look at the numbers 12 from the first term, 4 from the second term, and 8 from the third term, the number 4 is a factor of all three of these numbers. I'm going to bring that number 4 out, and I will put the result that I have in just a moment inside parentheses. Now I'm going to look at the variables, and if I look at the y variables first, I have a y cubed in this term, I have a y in this term, and a y squared in this term. There is a common factor of y. I could factor a y out of each of these. I could divide y cubed or y squared or y all by a common factor of y. So I'm going to indicate that by putting the y out front. Finally, I'll look at the z variable. I have a z here, a z squared in this term, and a z cubed here. I can factor a z out of each of those. Now I'm going to put some parentheses here to indicate that I multiplied the factor 4yz times something else in order to get the trinomial that I have at the start of the problem. And the way I know what it is that I multiplied by, I just take the first term and divide it by the common factors that I factored out. 12 divided by 4 is 3. Y cubed divided by y, using our properties for exponents that we learned last week, would be y squared. Z divided by z would be 1, or it cancels out. What you're really doing, and if you need to do this off on scratch paper on the side, that's fine. We're taking this first term, 12y cubed z. We're dividing it by the factor that we factored out and simplifying the result. 12 divided by 4 is 3. That's where the 3 came from. Y cubed over y gives me a y squared in its place. The exponent for y is 1. Y to the third over y to the first, using our properties of exponents, would be y to the 3 minus 1 would be y squared. And then the z's are common factors, they cancel. So you see I have the 3, y squared is left. And that's what I'm going to do for each term. This is harder to talk about and explain what you're doing than it is to actually do it. Now we look at the next term. I have a plus sign here. I'll keep the plus sign. 4 divided by 4 cancels out. Y divided by y cancels out. Z squared divided by z is plain old z. I will show you a trick that you use here in just a moment to know whether or not you've done this correctly, to have some confidence in your technique or your answer. Finally, the third term. Negative 8 divided by 4 would be negative 2. Y squared divided by y would be y. Z cubed divided by z would be z squared. And so the result is 3y squared plus z minus 2yz squared. The little trick that I said I would show you to, how confident do you feel that you did this correctly? It's easy to find out. Because what we're saying, if I were to multiply 4yz times this factor, this expression, each term inside, what I would end up with is what I started with. If I multiply 4yz times 3y squared, the 4 times 3 would give me the 12 in the first term. Y times y squared would give me the y cubed, and then z times 1 would be z. So every factor here is accounted for by the product of this factor that I factored first term. And you do the same thing. 4yz times z, you give me 4yz squared. 4yz times negative 2yz squared, negative 2 times 4 gives you the negative 8. Y times y gives you the y squared. Z squared times z gives you the z cubed. This is your answer. This is the product of factors that when I multiply them together give me the expression that I started with. Now what you don't see right now, and you won't until the next section in the text, why are we doing this? And the reason is it allows us to simplify more complicated polynomial expressions. So I'm just going to ask you to trust me for now that this is a skill that will serve you in good stead in the rest of the semester, and work on mastering the skill. It really is easy. With practice it becomes easier, and I'd encourage you to keep practicing. So that's problem 4. We'll do problem 6 next.